Hi, this is Miss Pellegrin, and today we're going to be looking at Module 4, Lesson 10, Simple Interest. In order to find simple interest, we're instructed to use the following formula, which is that the interest is equal to the principal. Our principal is the amount, can be the amount borrowed. Another keyword would be invest. Times our rate, and our rate is going to be a percent, and then the time is usually, as it says right here, per year, but it could be months. We are going to look at it yearly though, and so it says also that R and T must be compatible. So in other words, if one mentions a month and the other mentions a year, they have to be the same. So you would have to do and change months to years to where they're the same. Example 1, can money grow? A look at simple interest. Larry invests $100 in a savings plan. The plan pays 4.5%. Okay, giant percent sign. We said that's going to be our rate. Remember, a percent is always over 100, and that's 4.5. In other words, it's the whole number 4, and then 1 divided by 2, which is 0.5. So 4.5 over 100 is equal to, the decimal form of that would be 0.045. Remember, we've always got to use it as fraction or decimal form if it's a percent. Interest each year on his $100 account balance. So our first question says, how much money will Larry earn in interest? Okay, so we're looking for interest. So that was our I. After 3 years. So that is our time, our T. Okay, and then the second part of it says after 5 years. So let's just do 3 years first. Okay, so let's label. What are we looking for? We're looking for I, P, R, and T. Interest, principal, rate, time. And what do we know? Okay, so first of all, we have the percent, which is, in this case, our rate. Now that gets confusing, having a P and you're putting a percent in the rate. So the rate we said was 0.45, and then the time, we were given that as well. That's going to be 3 years. And then we said interest was what we were looking for because it says how much. So this is going to be our I. And so there's that word invest, $100. So 100 is our principal. All we're going to do now is plug it into our formula. I is equal to PRT. So I, we don't know, equals P was 100. R, we're multiplying here everything. So R was 0.045 times, and then our time was 3. So I is equal to 100 times 0.045. 100 times 0.045 is going to bring us right back to the 4.5, because remember, to get it, we divided by 100. So if we multiply by 100, we're going to go right back. So 4.5 times 3. So the interest is equal to 4.5 times 3, which is 13.5. So interest is equal to 13.5. Interest is an amount of money. So this is $13.50 in interest after 3 years. So that's after 3 years, and then the second part of it asked us for what about after 5 years. Well, the only thing changing here is the number of years, is our time. Okay, so I is equal to PRT. Again, we don't know I. We do know P is 100. Our rate is not changing. But what is changing is the number of years. So I is equal to 100 times 0.05. We already said was 4.5. That didn't change. The only thing changing here is the number of years. So the interest is equal to 4.5 times 5 gives me 22.5. 22.5. Again, interest is the amount of money that you're earning. So we're earning $22.50 in interest. Not in total, but in interest after 5 years. Okay, did we do everything? Yes. After 3 years, after 5 years, got both my answers. 2 boxes, perfect. Okay, so I'm going to keep going. Part B, how can you find the balance of Larry's account at the end of 5 years? So if we look back up there, it says that he had a $100 account balance. So what would you do? You would add the interest after 5 years to the beginning balance. And so what would that look like? After 5 years, it was $22.50. And then we're adding it to the original, or what we started with, which was $100. So we are left with having, after 5 years, now he has $122.50. And all that happened, he didn't put anything into the account to get the $122.50. He had interest on that money, and his interest rate was 4.5%. Okay, so we're going to take a look at a couple of things. We're going to look at this table. Okay, so in this table we have that equation. Interest is equal to the 100 times that rate of 0.045 times however many years. And after 1 year, if we plug that in, 100 times 0.045 times 1, we get $4.50. And we do not have to do an equal sign between. So if we did 2 years, we would do 100 times 0.045 times the 2 years. And we get 9. And then after 3 years, 100 times 0.045 times 3 years. And there's that $13.50. After 4 years, 0.045 times, 100 was the first one, whoops, equals, times 3 years, we said. Okay, whoops, I did 3 years again. I was supposed to be doing 4. Okay, so what's happening here? So it's increasing $4.50 every single time. So using your calculator, what do you observe when you divide I by T for each year? So T is the interest earned after T years. So you're taking this number and you're dividing it by this. You're taking this number and you're dividing it by this. So go ahead, do that in your calculator. This number divided by this. This number divided by this. This number divided by this. And so you should be getting that $4.50. That is your y divided by your x. So that gives you 4.5 is the ratio. So what is the constant of proportionality? The constant of proportionality there is 4.5. So what that means is for every year, the constant is 4.5. So if we multiply 5 times, whoops, I'm not on draw. 5 times 4.5, let's see, 5 times 4.5, we get $22.50. So that's his interest after 5 years, which is what we had up here. After 5 years, the interest was $22.50. Okay. What other representation could we use to show the relationship between the time and the amount of money is proportional? So we have a table here. What else can we use? And that's right, we can use a graph. Here is that graph. Oh, wait. There used to be a question there. What are the characteristics of the graph? We have a title. We have the amount. So we have our y. Let's zoom out a little bit. Okay. And we have the time in the years. Oh, that's everything. Okay. So what are the characteristics? There's that question. And those were some of the characteristics that we had. By looking at the graph of the line, can you draw a conclusion about the relationship? So what do we have here? What kind of line do we have here? That's right. It is straight. It is a straight line, and it is going through the origin. So it's a straight line, and it's going through the origin. And so therefore, it is proportional. Just like our table was, our rate of 4.5% is not changing. It's the same thing all the time. What does the point 4, 18 mean in the terms of the situation? Okay, so 4 is our x, and our x is talking about the years. So 4 years, and then we go up, and we go to 18. Here's that 18. That's the point. And 18 is talking about the amount of interest. So after 4 years, the interest is $18. That's how much he would earn after 4 years. What does the point 0, 0 mean? Okay, so this point right here. So same thing. We look at our x and our y and see what does that mean. We always start with that x. So after 0 years, we've earned 0 money. We can't earn money when we first start opening the account. We have to have it open for at least a little bit of time before we actually start earning that money. What does 1, 4.5 mean? Okay, so 1 and then 4.5, that's that point right here. So after 1 year, we've earned $4.50 in interest. Okay, so we're talking about our y, and then we talk about our x, and then we go over and we talk about our y. And we just use our labels. That's why we like to have our labels there, so we know what we're talking about. And then finally, what equation would you use? And we could use the equation. We could use the equation I is equal to 4.5 times t. Because every time we multiplied 4.5 times the number of years, it gave us how much interest that it would be. Notice that is in y is equal to kx.